this is Jo from Maths Tutor Me. Today we're doing a topic called factors, multiples and indices, and we're learning about factors today. So last lesson we learned about multiples, which is basically like times tables or skip counting to find the multiples. But factors are a little bit different. It's dividing. When we take a whole number and it divides exactly into the whole number, that is called a factor. So for example, 20 divided by 4 divides exactly to give us 5. Therefore, 4 is a factor of 20. So basically what that means is we're looking to find the factors of a number, we're looking for the times tables that will give us that number. So factors that will give us, times tables that will give us 20 as an answer. So 5 times 4 are two numbers that will multiply together to give us 20. So they are both factors of 20. You could also have 2 times 10 to give 20. So they are factors as well. And 1 and 20 would give you 20. Okay, so we need to be able to find all the factors of some given numbers. So like here in example 1, find all the factors and then as pairs, factor pairs, and then list the factors in ascending order. So for the number 15, to find the factor pairs, I want to find things that times to give 15. Start with the smallest number you can think of, which is always 1, and 1 times by 15 gives you 15. So 1 and 15 is the first factor pair, okay? Two numbers that multiply to give 15. Then you just want to increase from 1 and go through all the numbers until you can't find any more factors. So if I go to 2 next, 2 times something is not going to work because I'm not going to be able to get 2 times anything to give 15. So I move on to 3 times. 3 times 5 gives me 15. Now 3 and 5 are pretty close together. The only number that's left in between to try is 4, and 4 is not going to be a factor of 15. So that's it. Those 4 numbers are my factors. So to list them in ascending order, I would get 1, then 3, 5, then 15. Kind of goes down here, up there. Let's try that again for question 24. Listing all the factor pairs. So 1 and 24 is our first factor pair. Increasing down below 1, we would go to 2. 2 times 12 gives us 24. Going on to 3. 3 times 8 gives us 24. Moving on to 4. 4 times 6 gives us 24. And these numbers are getting pretty close together now. The only thing is left to try is 5, which is not going to work. And then we keep going to 6. We're on this side, and we're just going to get the same pairs again. All right, so that is it. They are all the factors. So to write them in ascending order, we just have to go down here, up there. So 1, 2, 3, 4, 6, 8, 12, and 24. Okay, now that we can find factors, we want to be able to find the highest common factor of two numbers. So we need to know the factors of those numbers before we can find the highest common factor. Now we don't always want to be listing factor pairs all the time. It takes up a lot of room and can be time consuming. So what we can do, we still need to find the factors, but I'm going to write it in a slightly different way this time. So to find the factors of 18, I'm still going to start with 1. 1 times 18. I'm going to write the 18 down here, and then I'm going to put all the numbers in the middle. So 1 times 18 is 18. Then I'm going to go on to 2. So 2 times 9, okay, gives me 18. Then 3 works. 3 times 6 gives me 18. So there's still 4. 4 times, no, that's not going to work. 5 is not going to work. And 6, we're up to here. So they are all the factors. We've put them straight into a line of ascending factors there. We have a bit of a gap here, but that's okay. They're still in order. So now for 45, doing the same method. 1 times 45. 2 is an even number, so it's not going to work for this. 3 is going to work. It's a bit of a tricky one. 3 times 15 gives us 45. 4, an even number, that's not going to work. 5 is going to work. 5 times 9. Okay, that's good. Keep going now. Is 6 going to work? No. 7, no. 8, no. 9. So they are all the factors of 45. So now we want to look at our two lists, starting with the highest number, because we want the highest factor we can find, and see if it's in the corresponding list. 9 is right there. So the highest common factor, which we can write as HCF, highest common factor, is equal to 9 for that question. Okay, let's have a look at B. Let's practice that again. We want to find the highest common factor of 48 and 60. So these are bigger numbers, and bigger numbers tend to have more factors. So it's really important that you know your times tables pretty well when doing questions involving factors and multiples. So it's a good thing to practice when doing this topic. Okay, so 48. 1 and 48 are going to be factors. 2 and 24. 3 is also going to work, and 3 goes with 16. Okay, that's a bit of practice. You need to work that out. Maybe you could do a little division sign over on the side to see if one works. 4 is going to work. We might recognize that one as a 12 times table. 4 times 12 is 48. 5 is not going to work. 6 is going to work. 6 times 8. And then 7's the only thing in between there, which is not going to work for 48. All right, on to 60. We have 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. 7 and 8 and 9 are not going to work. So that is it. There's the list of factors. All right, looking for the highest common factor, starting at the high end. 48 is not in here. 24 is not. 16 is not. But 12 is. So 12 is the highest factor in both. So HCF is equal to 12. All right, question 3. This is a bit of a practical question here where we can use our factor knowledge. A grocer is making up a fruit basket. He has 60 apples, 45 bananas, and 105 mandarins. He wants to use up all the fruit. What is the maximum number of fruit baskets that he can make? Now, if I can find the highest common factor of each of those numbers, then that would be the number of fruit baskets that we could make. So we've already actually found the factors of 60, so we can just copy those from here. That will save us some time. Okay, there they are. Then we want the factors of 45. Oops, arrow for that. 45 we actually did down here. So they were 1, 3, 5, 9, 15, and 45. And 105. Okay, so this is a pretty big number. 1 times 105. 2 is not going to work. 3 is. 3 times 35 makes 105. 4 is not going to work. 5 times by 21 gives 105. 6 doesn't work. 7 times table, so 7 times 15 makes 105. 8, no. 9, no. 10, no. 11, no. 12, no. That's it. We found them all. All right, so looking for the highest common factor in those numbers. All right, let's look at the 45. It has the least number of numbers to check. So 45 is not in that list. 15 is in there and in there. So 15. So the maximum number of fruit baskets that can be made is 15. Where can I write that? Therefore, 15 baskets. Okay. And B, so now that we know we can have 15 baskets, how much of each type of fruit will one basket hold? Well, if we have 15 baskets and we had 60 apples, okay, so we want to divide those apples up, okay, so 60 divided by 15 is 4. We could have 4 apples in the basket. Bananas, we had 45. 45 divided by 15 is 3. And mandarins. Okay, 105 divided by 15 is 7. Okay, so our fruit basket can have 4 apples, 3 bananas, and 7 mandarins. Okay, now it is time for you to have a practice. See if you can do what we've just been learning about. So I'd like you to pause the video and give these questions a go. Be particularly careful with my wordy question over here, number 3, and then restart to see the answers. All right, number 1, find all the factor pairs and then list the factors in ascending order. So factor pairs, 1 times 12, 2 times 6, 3 times 4 would be my factor pairs. So in ascending order would be 1, 2, 3, 4, 6, and 12 would be my answer. For B, for 36, the factor pairs would be 1 and 36, 2 times 18, 3 times 12, 4 times 9, 5 is not going to work, and 6 times 6. Now we don't need to write the 6 twice when we write our list. We go 1, 2, 3, 4, 6 just once, 9, 12, 18, and 36. Question 2, find the highest common factor of 42 and 63. So listing the factors of 42, we get 1 and 42. 2 is going to work, 2 and 21. 3 is also going to work, 3 and 14. 4, no, that's not going to work. 5 is also not going to work. 6, yes, 6 times 7. Okay, so there's the factors of 42. Now let's do it again for 63. 1 and 63. 2 is not going to work, but 3 is. 3 times by 21. Now, we could keep going and see if we could find more factors here, but you might have noticed as soon as we found what we found here, 21 in both of those lists there. So I can stop there because I'm not going to be able to find a bigger factor than that. So my highest common factor is 21. Okay, let's look at question number 3. How do we go with that? If there are 105 students in Year 7 and they are to be divided up evenly into classes of no more than 25 students in each. Okay, so what we need to do is find a factor of 105. Now, we actually listed the factors of 105 in one of our previous questions, if you remember. They were 1, 3, 5, 7, 15, 21, 35, and 105. Okay, so if that's the factors of 105, we need to divide up these kids into classes of no more than 25 students. So we can't have 105 kids in one class. We can't have 35 kids in the class. But the next biggest number is 21. Okay, so if there are 21 kids in the class, that would evenly divide our students up, which is actually the answer to part B down here. How many students will be in each class? The answer is going to be 21. Okay. For part A, how many classes are needed? Now, how many groups of 21 do we need to get to 105? Well, we would have 21 for the first class. Then we would have 42. These are doing the multiples of 21. Then we would have 63 and 84, and then we would have 105. So 1, 2, 3, 4, 5 classes. 5 classes. And there it is. You need 5 classes, and there'll be 21 students in each class. Okay, that's it for the lesson today on factors. Keep practicing and join me again next time. Bye.